Right, we want to proceed to solve this equation for x, y, and z. First, we write down the system of linear equations. This means that we can be able to write down the corresponding matrix equation. So you have 1 minus 1, 1. We have 9, 3, 1. We have 1, 1, 1. X, Y, Z. Which is exactly 13 minus 7 minus 1. So what do we get at this point? Right, so we note a couple of things that this matrix equation, basically, obviously, the matrix equation of the form, which is of the form AX equals B. In which case, therefore, we let A be the same as with the coefficient matrix, which is 1 minus 1, 1, 9, 3, 1, 1, 1, 1. So now this would be 1, 3, 1, 1, 1. Minus 1, 9, 1, 1, 1. And if you block this and that, we have 9, 3. So now this one becomes exactly 1 and 2. 3 minus 1, 2. 9 minus 1, 8. 9 minus 3, 6. So this is exactly 16 if you add everything. So it means the determinant of A is 16. So now we also let AX be the same as, okay, you put the B column here. Which is minus 1, 3, 1, 1, 1, 1. This implies that, okay, the determinant, we can get the determinant in a similar manner, but it's very easy to show the determinant of A is also 16. We shall also form another matrix we shall call A sub Y. You put this one in the second block. So yeah, the first column is exactly 1, 9, 1. The B is exactly 13 minus 7 minus 1, and the last one is 1, 1, 1. We can be able to find the determinant in a similar manner, and it is easy to show that in a similar manner like we did found the determinant of A, the determinant of A sub Y is actually minus 112. So you have this. Okay, moreover, we have that AY or AZ, excuse me. So with AZ, AZ would be 191 minus 131. And the last column is 13. The last column is 13 minus 7 minus 1. This means that AZ, the determinant of AZ, is very easy to show that it is actually exactly 80. It's exactly 80. It is 80. 80. Like so. Now then, what are the required values of X, Y, and Z out of this? What are the required values of X, Y, and Z out of this? So it is clear from this that thus we can say that X the determinant of A, which is 16, the determinant of AX, A sub X is 16, but the determinant of A is also 16, and the result is 1. We also have Y, the determinant of AY, determinant by determinant of A. Determinant of AY is minus 1, 1, 2. Determinant of A is 16. And this is minus 7. Right. Last but not least, we find one more determinant, determinant of Z. So the determinant of Z, we find it also. So what is the determinant of Z? Rather, what is the numerical value of Z? So the numerical value of Z, first and foremost, is the determinant of AZ divided by the determinant of A. So we write that one down. So the determinant of AZ divided by the determinant of A. What is the determinant of AZ? 80. The determinant of A is 16, and the result is plus 5. And therefore, the conclusion after everything here is that X is minus 7. X is 1, excuse me. X is 1. Y is minus 7. Z is 5. Like this. And these are the actual numerical values of X, Y, and Z. And we're done. Thanks, everyone. Goodbye to you. That was Cramer's rule. Okay, goodbye.